Hey everybody, welcome back to my workshop. It's been quite a while since I messed around with any high voltage. It's the little series I did of a couple videos where I was messing around with a microwave oven transformer and drawing a couple of meager arcs, trying to get a Jacob's ladder to work and not having much luck with it. It actually was a very, very popular video. So since it had been a while since I had done anything, and I had been kind of holding on to a couple of things here and there, with the thought of maybe cannibalizing them to go back to some mad scientist type of experimentation, I figured maybe I'd do a video right now on a old ozone generator that I have. So what I have here on the workbench today is a ozone generator. This particular type of ozone generator is used in hot tubs. Hot tubs use two different hot tub ozone generators have two basic designs. There's what's called a UV unit, which actually uses a high-intensity ultraviolet light source to generate the ozone. The second type is called the CD, which stands for Corona Discharge type. So the UV light types wouldn't be good for high voltage experimentation because they do have a high voltage source in them, but it's just a ballast for firing off the UV lamp. The UV lamp inside those units looks like a miniature fluorescent tube, but it doesn't have the phosphorus coating on it, so it's clear glass. And when it's on, it actually generates very high intensity UV light, so you would never want to look at it, even though it might not be appearing to harm your eyes. The light that is out of the visible spectrum is cooking your retina as you look at it. So this is a Corona Discharge type of unit. So this actually has a high voltage power supply inside of it. And on the really old ones, they had a pretty elaborate supply. On these, they just use a solid state module. There aren't really any user serviceable parts inside. And over time, these do go bad. This particular one came out of a Hot Springs hot tub, and it's got quite a few. It's a 2008, but I don't remember when this was taken out of service. So I already unscrewed it. Just open it up to show you what's inside. These run off of the control pack inside the hot tub, so they basically are made to usually plug directly in through a special plug. So the other thing you have to be concerned about with these is, are they 120 volt AC or are they 220 volt? Because many hot tubs are 230 volt. This is a 120 volt unit. So this can run off of regular house current. If you have one that is 230 volt, that's a whole nother can of worms, and you really shouldn't even think about messing with that. So before we get into anything, once again, a disclaimer. This is not an instructional video. Anything you see in these videos, if you choose to try and do it on your own, you're going forward at your own risk.
Of course, we have the power cord, which...
I'm just going to cut that right off because, again, it's got that special plug on it. So all there is to this unit, it's pretty simple. We got the 120 volt AC enters here, goes onto this little circuit board, and this little circuit board is basically just a place to have this fuse. And it looks like water may have gotten into this unit. There's some corrosion on the fuse there. Then the power leaves the circuit board and goes into this module. This module basically contains a switch mode power supply designed to generate high voltage. So inside here are several components that are all what they call potted. In other words, they put all the electronics into this box. They have a switching transistor, probably a MOSFET, that I could see inside there, that is attached to this heat sink. And then they pour in this potting stuff, which hardens like an epoxy and keeps all the components from being able to move around and be exposed. and it helps protect them from any moisture or anything like that, but it also basically makes this very, very difficult to service if you wanted to try and service it. Then the output, the high voltage output, comes out of these two insulated wires here and goes into this little cavity, for lack of a better term, and inside here is where the magic happens, but we don't care about that because we only want the high voltage. So let me just get a nut driver to unscrew that little nut on the end there. This looks like it's just a regular screw. Alright, so we've got our dodgy wiring set up here. I guess before I even bother doing anything, I should check and see if that fuse is good, because if that fuse is blown, this is probably a bad unit anyways. Looks like that fuse is good. It's hard getting a good connection on that corrosion. Alright, so I'm just going to plug it in and see what happens. Oh, I hear a lot of noise coming out of there. It's doing something. Okay, so now that we know it's doing something, let's see if we can't rig a way to get these close enough to each other to see if we can draw any kind of an arc. I got this piece of about 3.5 foot long of Schedule 40 PVC conduit. So I'm going to use this as an insulated probe. All right, so we drew a little arc and then it immediately blew the fuse, because essentially once the arc was established, the current went through the roof and that drew too much current on this fuse, and that was all she wrote. So it is a high voltage supply, but it just can't handle the rush of current that happens during an arc. So this probably would not make a suitable candidate for our experiments here, unless we figure out a way to limit that current. Alright, so I just looked at the cover of this thing and noticed that the current at 120 volts that it's supposed to draw is 0.05 amps. So half of a tenth of an amp. So it seems to me like that fuse was probably very small. So what I did now is I put a 1 amp fuse in. I didn't take a look at the fuse was stuck in there from corrosion, and it broke when I went to take it out. So I just kind of threw it away, and then I realized afterwards, unlike a lot of things, there's nothing on the circuit board to tell me what the fuse size was. So I should have looked at the size of the fuse. But I'm betting that fuse in there was really small, like a half amp at best. So I put a full 1 amp fuse in there. So of course that's not good, but we're just, we're just fooling around anyways. So now with a 1 amp fuse in there, let's see if it can stand to hang with us just a little bit longer before it quits. Do this. Nope, pop that fuse right away. All right, so unfortunately I think this is going to be a fail. I'm not saying that there's anything wrong with this unit. I think this unit is probably working the way it's designed to work. I'm just causing too much current to flow through that primary circuit. So I think I'm going to stop there. The reason why I want to stop now is because I don't want to fry this unit if I haven't already done so. In fact, I'll do a quick check. I'll just power it up with a new fuse just to see whether or not it still makes that. Alright, got a new fuse in there. Still works. Obviously, if I draw an arc again, I'll just blow the fuse again. So I'm going to stop right there. And the reason why is because I've got a good high voltage power supply for if I can think of a project, or if anybody has a suggestion for a project for this type of power supply that they'd like to see me screw around with. Let me know in the comments.